Okay, welcome back students. So we have discussed about the Maxwell's displacement current, and we have discussed that there are four fundamental equations which comprises the whole electric field concept and the magnetic field concept in physics. So in the second topic we are studying about the Maxwell equations. Maxwell found that all the basic principles of the electromagnetic that can be framed in terms of the four fundamental equations, and these four fundamental equations are known as Maxwell equations. And assuming that no magnetic or the dielectric material is present, so the four basic equations can be stated in the following form. So first Maxwell equation is Gauss law of electrostatics. We are already familiar that according to Gauss law, electric flux through a closed surface capital S is 1 upon epsilon naught times total charge enclosed by that closed surface, where epsilon naught is the permittivity of free space. And in mathematical form, it is given by closed integral over the given surface as E dot ds is equal to q upon epsilon naught. And from this equation, we are able to find that the charge on an insulated conductor that reside only on its outer surface. It does not enter within the surface of insulator. And the second important conclusion is that electrostatic force between the two charges is inversely proportional to the square of the distance between them. Now move to the second Maxwell equation, and that is known as Gauss law of magnetism. And we know that magnetic flux through any closed surface is always zero. So in mathematical form, it is given by surface integral over the closed surface as b dot ds is equal to 0. So from this equation we are able to find that isolated magnetic poles of the magnetic charges do not exist. So it explains the absence of the magnetic monopoles. So that means magnetic monopoles cannot exist. Third fundamental equations, that is the third Maxwell equation that comprises electric and magnetic field, is given by Faraday's law of electromagnetic induction. We know that a changing magnetic field produces an electric field. So hence an induced EMF is set up in the given circuit, and that is given by rate of change of the magnetic flux linked with the closed circuit. So we know that line integral E dot dl is equal to minus d phi b upon dt. Phi b is the magnetic flux which is changing with the time, and it is producing the electric field. And also E is equal to minus d upon dt, surface integral of the closed surface, that is b dot ds, because phi is equal to b dot ds. So this was the third Maxwell equation, that is known as Faraday's law of electromagnetic equation. The fourth one is that was modified by the Maxwell, and that is known as modified Ampere circular law. According to this law, line integral of the magnetic field around any closed surface or the circuit is equal to mu naught times the total current. Initially it was only simple current, that was conduction current, but now total current is the sum of the conduction and the displacement current that is passing through the given closed circuit. So b dot dl over the given closed circuit, that is given by mu naught within bracket sum of conduction current plus sum of displacement current. So displacement current arises due to the changing electric fields, and it is given by d phi upon dt into epsilon naught. So therefore Ampere's modified law take the form mu naught within bracket IC conduction current plus epsilon naught d phi e upon dt, where phi e is the electric flux. So that means these equations give the idea that conduction current is not only present in the circuit, but there is a displacement current, and combination of the both current with the changing electric field produce a magnetic field. So that means conduction current and the displacement current both are responsible for producing a magnetic field, not only the conduction current. So this is all about the today students, and there are some questions that is more important and they are being asked in the CBC exam. First question is very important. What is displacement current and what are its property? Note it. First question is what is displacement current and what are its property? Second question is what are electromagnetic waves? Definition of electromagnetic waves and how they are produced. Third very important question is what are the properties of the electromagnetic waves? Mostly 3 or 4 properties are asked, but you have to go through all the basic property of the electromagnetic waves. Next question is very important. What are the 4 fundamental equations of the electromagnetism? Yeah, what are the 4 Maxwell equations? Explain them. Or the second question, or the other form of this question is how Maxwell was able to give the result that magnetic field can be produced with the changing electric field. So these are all the questions, and sometimes a question is also being asked to draw the envelope of the electromagnetic waves, and the form of the question is show the propagation of electromagnetic waves along x-axis or y-axis or z-axis. So that means if the propagation along x-axis, then you have to show the propagation along the x-axis. If z-axis, then you have to show the propagation along z-axis. And the magnetic field vector and the electric field vector should be perpendicular to each other. So these are the some of the important questions about today's topic. So write the answer to the given questions, and tomorrow we will move to the next very important topic. What are the sources of the electromagnetic waves, how electromagnetic waves are produced, and we will discuss about the transverse nature of the electromagnetic waves. And there are some numericals that will be given to you on the basis of the properties of the electromagnetic waves. That's all about the today. Thank you very much. For any query, you can send your queries in on my personal WhatsApp. Thank you.